Alright, YouTubers and fellow enthusiasts of radio stuff, be it RC, be it ham radio, be it whatever, I'm going to show you what a Spektrum DX7s RC transmitter and a DX5e transmitter look like on a service monitor. A service monitor is a very, very expensive device, especially when you have one like that can be used for a multitude of different things when it comes to testing radio communication equipment. You know, be it transmitters, receivers, be it their actual internals, such as their filtering and receiver testing and stuff like that, receiver sensitivity and everything else. So anyway, this particular service monitor is only good for up to 1 gigahertz or 1,000 megahertz. Now, while that may sound like, well, that's not very good, it's like, well, screw you. That machine in its day cost $30,000. Anyway, so I am doing the same exact thing that they do in that machine, except I just did it on my own. So here's what I'm doing. These radios transmit in the 2.4 gigahertz spectrum, same thing as the Wi-Fi, right? So in order for me to be able to see or display on the service monitor in the spectrum analyzer mode the frequency versus amplitude, or the spectrum analyzer display, is I have to use a circuit. What this circuit, quote unquote, consists of a local oscillator, or a 1.87 gigahertz oscillator reference that is from an old, probably a Sprint PCS, something. It's from an old Sprint PCS base station, a cellular base station. And it goes into a mixer, and yeah. So anyways, this is how it works. The local oscillator there will generate a 1.87 gigahertz or an 1870 megahertz signal, and is fed into the local oscillator port of this mixer. RF from the transmitters, or whatever, it gets fed into the RF side, and then the resulting comes out on the I, which means IF, the intermediate frequency. So assuming that these things transmit around 2450 megahertz minus the local oscillator frequency, 1870, the resultant is 580 megahertz. So I have the service monitor set to 580 megahertz. Now, let's turn on a DX5e transmitter and see what it do. And there it is. You see part of the waves. Now this one was kind of neat, and this one has two that just pop up in random different areas. Okay, so we'll turn this one off, and we'll turn on the DX7, which is supposedly got some better technology and stuff in it. Now you should also have noted as to how fast those signals were going, and there was just a couple and you saw. The DX7 has a whole bunch. You see they're a lot faster. I'm not going to say they're stronger because both the transmitters are, what, about 100 milliwatts. So you see it's a whole lot faster, which is kind of cool. Alright, that's pretty awesome. And now let's power both the transmitters on together and see what they do. So you see that they, at least the DX7 anyway, avoids the other transmitters. So you see that they're not talking to each other, and even though, yeah, they're pretty close right there, they're still not going to bounce in. And the DX7, because it bounces around so fast, that is called frequency hop spread spectrum. That means it is bouncing around in the frequency. So anywhere from 2.4 to 2.5 gigs, it is bouncing around, always maintaining a signal. So when someone says that my receiver lost link or lost its bind, no, that's not true. It's because you flew your receiver with a dead battery, and that's the only way it's going to lose its bind, if ever. Now, I have had my airplanes for a year and a half now. I've never had to redo their bind. I've never lost communication with them. So, yeah. Anyway, so that's the first thing. Alright, you saw how that works. That's kind of cool. Now, what also operates on this spectrum of 2.4 gigahertz? Wi-Fi. So let's take into consideration some magical things here when there's other signals that get into the area that the transmitter, kinda, if it's a telemetry transmitter, but also the receivers have to contend with. Just a minute. So, for those that are having issues with any 2.4 gigahertz stuff with RC transmitters. I really don't care if it's a high-tech, if it's a Gropner, whatever it is, if it's a Spektrum, it's a Futaba. They're all going to suffer the same thing. They each got their cool little names and stuff like that, and they do all their technologies to mitigate this. But if you are flying in the city, or anywhere where near anybody has that thing on the wall, a 2.4 gigahertz wireless access point, there is going to be lots of that. That signal right there is the Wi-Fi signal from the phone. And it's not nearly as powerful as that thing is, but your receiver, it picks up all of that. So that right there, that signal from there, is going to cause what's called receiver desensitization. What that means is there is so much strong signal on right near the same channel, and also on the same frequency band that your receiver's on, that's going to cause it issues. Guaranteed. So, question is, what can you do about it? Well, nothing. Because no one wants to fly with 72 megahertz anymore. It's not cool. What are you going to do? So, 72 megahertz was set aside, 72 and 75 megahertz were set aside specifically for RC models, so you don't have, oh, it's done downloading, so you don't have that issue. Anyway, kind of a neat setup. Maybe I'll figure out how to see what a cell phone does, huh?